Okay, let's look at the homework 1.1, 1.2, problem number 6. All right, so we want to come up with a differential equation of this form such that the solution curve has a normal line always going through this particular point here. So this is a point right there. All right, so let's say, so it's going to look kind of like this. Say you have a graph like that. Right, so let's take any point on that graph since we don't know the location, so I'll call it x comma y. All right, then you look at the tangent line, normal line, so it's perpendicular to this guy, and this guy always go through this point 0 comma 1. Right, so it's perpendicular here. Right, well, we can think of it as perpendicular to the tangent line. So tangent line looks like this. Right, so I'm going to label these. So this is tangent line, and this is the normal line. All right, then we can look at the dy over dx as the slope of the tangent line. So here, slope of this tangent line and can be expressed as dy over dx, because derivative always tells us about the derivative slope of the tangent line. All right, so if you want to find the slope of the normal line, so slope, so this means that and slope of the normal line, which is perpendicular to the tangent line, which means that the slope has to be negative reciprocal of dy over dx. All right, and since we know that this actually also goes through point 0 comma 1, and this general point on the graph, we call it x comma y, we can use a slope formula to find the same slope. Right, so this is actually is equal to, right, so let's use the slope formula. So here this point is 0 comma 1, right, and you can think of this as x1 comma y1, right, and you can think of these guys as x2 comma y2. Right, so slope formula tells you that it's a y2 minus y1, so you can get, so that's going to be a rise is y minus 1, and over x2 minus x1, so that's going to be the run, so x minus 0. All right, now we have a differential equation, so we just need to rewrite it in that form. All right, so first thing we can do is we can simply take the reciprocal of both sides of the equation. So we have, so it's going to be still negative, but we have dy over dx, right, which is equal to, right, x over, so we just have to write it upside down, y minus x. Right, then we just need to get rid of this negative sign, so this is going to be equal to, right, so we can just either multiply or divide, so I'll just say divide by -1 That way we have an equation of the form dy over dx equals, right? Right. Instead of putting a negative sign in front, I'll keep x as it is, and I'll just multiply the denominator by -1. So that's going to be negative y plus 1. So I'm going to write it as a 1 plus negative y. Right? 1 minus y, I should say. Right? So this is the differential equation that we're looking for. Right? Then let's answer the second part of the question. Can you guess what the graph of G looks like? All right. So think of having a whole bunch of normal line through 0, 1. So I'm going to just draw a bunch of lines through 0, 1 like this. All right. And here as well. All right, and here as well. All right, then think of a line or the curve that intersect all these lines perpendicularly. All right, so it depends on where you start. So let's say if you start from around here, then you can see that we make sure that it's perpendicular here, right? Say perpendicular. And it's perpendicular to that guy, and perpendicular to that, perpendicular to that, perpendicular to that. So doesn't look great, but here this is perpendicular, perpendicular, perpendicular here, and a perpendicular here, and so on. And it could be down here too. So if you start from somewhere around here to perpendicular to that, perpendicular to that, perpendicular to that, perpendicular to that, right? So you have that, right? Can you see that these curves are going to be a part of a circle and centered at 0, 1? So it's going to be a family of, let's see, since it has to be a function, it cannot go all the way around. So it's either a top semicircle or the bottom semicircle, right? So the graph of this G is going to be a semicircle centered at 0, 1. All right, that's it. I hope that this was clear.